I am excited to be back in 2021 to continue some of the work that we started last year with the Tech on Demand in the Break Room series. It was a series of educational videos intended to help you and your team get prepared for the upcoming season. Well, we covered a lot of topics, I think 9 or 10 to be exact, and you can find a link to all of those, which are combined into one video playlist, and you'll find that link in the show notes or the video description. I am your humble host, Bill Calkins with Tech on Demand, and our goal is always to give you tips and tricks to do your best in the upcoming season for any crop that you're growing. This time, we're going to talk pansies, a fall and spring crop, and it's not going to be a one and done discussion because producing a fantastic pansy crop involves all sorts of different aspects of production, from seeding and propagation to all that time in the greenhouse to finishing and shipping. It's a complex crop. It's a multi-season crop. So we're going to break this whole thing down that way. And I'm joined by Dr. Will Healy, the Senior Technical Manager at Ball, who not only has worked with pansies for decades, but is also one of the best educators in our industry who can take complex topics like production and technical elements of growing and break them down to make them understandable. So Will, how's it going? And do you have any, thoughts on pansies before we jump right in?
Well, thanks, Bill. It's that time of year when we're going to probably grow the hardest pansy crop that you can, which is, of course, that fall pansy crop that really we start the seeding in the summer, during the heat of the summer, and everyone thinks pansy is a cool crop. And so we have to go and do something extra special. Well, no, we're going to basically go back to the basics, and we're going to hit some basics and have a great time kind of refreshing and rethinking how should we be doing our pansies? What can we do better? What should we remember? Because it's a very fast crop. You sow it for a couple of weeks and you're done. So you got to get it right from the very beginning. So it's a joy to be with the growers here to share some of my ideas and some of the experience of other growers, because growers have taught me a lot over the last 30 some years of growing pansies.
For sure, and that's really what the in the break room series is all about. It's information to share with your entire team to get everybody on the same page before you start a crop. So, Will, why don't you go ahead and share your screen and take it away as we start our discussion of pansies.
Sure, Bill. So we'll go ahead and we'll take a look at pansy production, because that's really where it all begins. So let's talk a little bit about what we need to do to be successful with our pansy crop. One of the first things that you really need to make sure that you're doing is you're starting out with your primed seed. What is primed seed? Well, that's seed that they've taken raw seed and they've treated it in such a way that it's just beginning to germinate all of the seed, because pansies are somewhat ununiform in their normal germination. So primed seed gets you all started at the same point. And the same point is really what we're going to try to do through this whole successful pansy plug program, is how do we make it uniform? How do we get everything to be dancing in the same way, so that you're doing a giant line dance with your pansies versus this random waltz thing that really never works well. So let's talk about some of the things that you can do. Remember, it all starts out because pansies are a water crop. It's very sensitive to ununiform watering. That's what screws people up. So make sure that you've got uniform water distribution in your flats. If you checkerboard, like the picture shows, where you've got some dry cells and wet cells at the time of germination, you really need to go back to your flat filling operation and make sure that you've got the right amount of water uniformly distributed through all of the cells, so that they're all uniform. Because if the soil is not uniformly moist, everything from that point on becomes non-uniform. So let's make sure you start there. Then let's make sure that when we're going to go cover, that we've got uniform covering. A lot of times people will have a half empty bin of vermiculite or whatever covering they have. And what happens is it doesn't distribute uniformly over those trays. So you're creating variability in the covering. And that, of course, just leads to lack of uniform germination, as we'll see why in just a moment. Should you use a chamber versus on a bench? The advantage of a chamber is not only do you have more uniform temperature control, but you can also have much more uniform moisture control. Why is that important? Is because, as you can see in this picture, is that you can, if you look at the germination, you've got some time, sometimes you have tall seedlings and short little seedlings, and that germinate at different times. What that tells me is that you had non-uniform moisture, so that some cells were wet, some cells were dry, some got wet, started germ, some didn't. And so the whole process is non-uniform. And that can occur when you sow your seed and you put it on a bench where it could be hot, it could be cold, could be dry, could be wet, and you're not uniform. Put it in a chamber, whether it's you're refrigerated or it's not. It's about 65 degrees Fahrenheit, about 18 degrees centigrade. And it just gives you a uniform moisture, so that if you start at the right moisture level at the time of sowing, the moisture then gets into the seed uniform and you hydrate that seed uniform. And once you hydrate the seed uniform, you're off to the races with all of the seedlings going at the exact same rate. So let's take a look at just a little science, because it's always good to have a little science to understand what are the steps in the process. And how are you screwing it up by not following the process? The very first step in a seed, and we got a nice little example of a barley seed, petunias, pansies, all seed has about the same characteristics. So we'll use this as an example. But one of the very first things that you do is the seed absorbs water. That water absorption has to occur, because think of that as the shotgun that starts the race. If you got some seedlings that start a second later, a day later, and 2 days later, well, they're not bad seedlings. They're just late starters. It's kind of like me and Bill. Bill is a sprinter, and he's out of that gate like a racehorse, whereas I'm kind of a tortoise, not moving quite as fast. So that's the problem that we run into when we don't get uniform moisture. Some starts fast, some start slow, because once you get it hydrated, then all of a sudden you trigger some gibberellins that basically then trigger a whole series of breakdown of the starches. And that's really important, because starches turn into sugars, sugars turn into basically the energy building block that get this whole process going. Because then all of a sudden this you get all that sugar there, and it basically causes the cells to start elongating and start growing and dividing and growing like very strong cells they should. At that point, the seed starts to crack, and the radicle the root starts to emerge from the seed, and basically the seed has germinated. Now, so the bottom line here, Bill, as you can see, is it's all about uniform hydration. What happens? So let's take a look at some seeds that have hydrated. So during day 0, we've gotten the moisture level to the correct level, and you can see the seeds are sitting there, and this is in the case of a petri dish, but this is what happens in your soil also. And if you go to day 2, notice down in the bottom corner of my picture is the day that this is happening. Notice between day 1 and day 2, you see a little bit of cracking on this prime seed, because remember, it's already primed, ready to go. By day 3, you can actually start seeing swelling, so that the radicle or the root is starting to actually elongating on a couple of seeds. And so that by day 4, what we have is that we got the roots starting to come out already. So, and as you can see by the picture, there's a couple of seeds that are just not quite there. They're a day or 2 behind, but they're all going to be within 48 hours from the start to the end of this whole population. Because as you can see, as you move to day 5, those seeds that were not quite cracked on day 4 are already cracked on day 5. And off they're going, and you've got some that already have elongated roots and some of them that are just starting to crack. So by day 5, either you're in synchrony and everything is happening, or we're off on different timelines. So basically what you want to make sure of is that you don't have continuous moisture from a level 5, and we've got other presentations that Bill will talk about in the show notes of where you can find them about level 5 and level 4, but you really don't want to be going from level 5 down to just level 4, because what happens is you start forming what is called a gel coat. here's a good example in this picture of the pansy seed, which has this kind of a mucus layer on it. In fact, if you keep pansy seeds or viola seeds, actually salvia does the same thing. There's a number of crops that do this. You feel that they're kind of slimy and slippery if you keep them too wet. That is the gel that basically the seed is not stupid. Let's remember, seeds survived. And how do they survive is if it's too wet. If they're all of a sudden they're saturated with water, they're not going to germinate because the roots, remember what my saying is, fish grow in water, roots grow in air. So if that seed is continuously surrounded by water, this is not a happy place for it. It really needs to have that air. So if you keep it continuously wet, basically it forms a gel. And that gel, what it does is it basically prevents oxygen uptake. So what you want to be doing is you want to make sure that you dry it back to a level 3, which is, of course, correlated to a specific weight in the tray. And then you can take it up to a 4, not to a 5, but just to a 4, so that it stays between a 4 and a 3. What does the vermiculite do? Well, the vermiculite sucks the excess moisture away, unless, of course, you've saturated so it can't suck any more water away. So you really want to use that as the vermiculite on the top and the soil on the bottom to make sure that you get enough water so that the seed will hydrate, but not so much that the gel ball forms. Because I think most of you who have overwatered your seeds and have seen this, where you keep it too wet, and what happens is then all of a sudden someone dries it out and bam, a whole bunch of seeds germinate simultaneously. And then you keep it wet, and then 2 days, 3 days later, you dry it back out, boom, another big burst of germination. That's a real indication that you're not managing that moisture. Primed seed will germinate within that 24, 48-hour window. They'll all come up and basically unfold their leaves. So remember, that gel is a bad thing if it starts forming because it prevents oxygen, which is required for plants to grow, is basically sealing the seed to saying, stop, it's too wet out here. So make sure that you go through this, take it up to 4, drive it back down to a level 3. On the sheet, I've given you some approximate weights for the different levels. Level 4 is about 1,400 grams. Level 3 is about 1,100 grams. Level 2 is about 800 grams. So that should give you some ideas of what should the tray weights be. Of course, everyone has a little different, and you need to test and check that, that webinar for that information. So now that we've got the seed germinated, that root has come out, what do we now need to make sure? But we've got to make sure that as the cotyledons, you go to the hook and then the cotyledons stand up and they unfold, that at that point, you need to start drying them back. If you keep them too wet, one of the things that you see really rapidly is you get this problem of root running, or you get these roots that basically they don't go into the soil because, of course, they're kind of like teenagers. Why should you work so hard to dig down in the soil if there's a lot of water up here? We'll just lay around and they'll splash water on me and I'm fine. And besides, if I'm up on the surface, there's also air because fish grow in water, roots grow in air. So you need that air. And so if you've got root running, so the roots running across the surface of the soil, that is basically a klaxon horn saying you're too wet. You need to dry these back to get those roots to go down and go looking for water. We want to have busy roots that are definitely growing. If you've not cut the moisture back to a level too fast enough, a lot of times what you'll see is this hypocotyl. You'll see it in the picture where it's that the hypocotyl is the area from the cotyledons down into the soil. If you've gotten the soil too wet too long, so when you get to the hook, you haven't started drying back down, then basically you'll start stretching that hypocotyl, because remember, it's just a bunch of cells that excess water causes it to stretch. Some other problems that we see many times is that you get big petioles so that the leaves stand up like rabbit ears. In this here, we've got a great picture where if you have the basically the right moisture where you dried it back down, the the petioles stay short and compact, and you get that nice short compact plant. On the other hand, if you fail to do that and you keep it too wet, then all of a sudden you start seeing this petiole stretch, and you get these tall, floppy ears that have to be controlled later on. Of course, the question isn't in how wet, but also how dry. We want to make sure that we're applying enough moisture to get to the bottom of the cell with one drop coming out of the tray. And of course, that is basically what is defined as a level 4. So you want to get that drop. If you don't, as you can see in this picture, if you're not putting enough water on, so you're just basically putting it on the very top of the cell, what happens is you get roots that grow around in circles. They grow horizontally at the top of the cell. That's telling me that you're not drawing the water down, causing the roots to search for water. Or if you don't have roots to the bottom, sometimes it's so dry the roots won't go into dry soil. So you do have to make sure you look at the soil, look at the bottom of the trays. Good growers always look at the bottoms of the trays and the top of the trays. Now let's shift gears because you've got your watering program under control. Let's talk about fertigation. What is your fertilization program? What we've got here is a chart that shows 3 different formulations of 13-2-13. So just because it says 13-2-13 doesn't mean that it's exactly the same. 13-2-13, of course, will all have the same amount of phosphorus. If we put 100 parts per million on of 13-2-13, we get about 6 parts per million phosphorus. We really want to have something in the teens so we're not limiting in phosphorus. It also has different micronutrients. One of the things that we've learned over the years is that micronutrients are critical for success of a pansy crop. Pansy crop that uneven, pansy crop that stall, pansy crops with abnormal growing points. All of these problems that affect pansies are all because the micronutrients or the phosphorus are not right. Nitrogen is good, but micronutrients and phosphorus are critical. So make sure that you've got a little bit of ammonia in there, but those phosphorus and micronutrients are so critical. Because remember, as I said, why do we have to have phosphorus? Phosphorus, you basically know your phosphorus deficiency if the cotyledons and lower leaves are purple. Phosphorus is needed for energy. It's part of the ATP that drives the whole system. So if you don't have phosphorus, you got problems. Iron and manganese. Iron and manganese are both very critical in chlorophyll and then the whole photosynthesis process. And you have to have sufficient amounts. Notice that these different formulations really aren't up to snuff with enough because you're only putting 100 parts per million of nitrogen on. If you're putting a full 200 parts per million, then you would have enough or you'd be in the ballpark of iron and manganese. So you need to, if you're using low levels of nitrogen, you really need to check what your micronutrients are and amend that fertilizer or buy a custom blend where it is already amended so that you have the micronutrients of iron and manganese. Very critical for uniform development. Boron. Boron is one of those nutrients that's very hard to take up under high relative humidity conditions. Very important in shoot and leaf development. You see a nice picture of this gnarly looking little plant. And what's happened there is the boron has been restricted just due to high relative humidity. I've got a great picture there, as you can see, Bill, where A is what we see when we look at the plants. You don't see humidity, whereas B picture is the exact same thing as what the plant is seeing. High relative humidity, kind of fog, that's very high, that's almost at the dew point, prevents water loss from the plant. And if you're preventing water loss from the plant, well, you're not taking up boron. Why? Because boron moves in the water stream. If you want to get boron uptake, you've got to have good water movement. And that's by keeping the humidity low. And you're saying, okay, I'm doing summer pansy production. There is not low relative humidity. So what do? Well, one is you want to make sure that there's no boron limitations. Notice that these 3 fertilizers of 13-2-13, the recommendation is 0.5 parts per million in the water that you're applying. notice that formulation A has 0.01, a lot less than 0.5. Formulation B has 0.1, 10 times as much as A, but still not 0.5. And of course, C has 0.08, which is, of course, again, not enough. So you want to make sure that boron is not limiting, so that when you have high relative humidity conditions, which typically happen at night in the summer, that you don't end up with boron deficiency, because this is really important. Later on, we're going to talk about pansy mottle, or as I refer to as pansy muddle, where we have a lot of problems, and it's all because your boron is not getting taken up. So let's make sure we've got plenty of boron. And remember, constant feed. Think about the crop time that you have to deal with, because the crop time is so short. You only have, first week is germination. You're probably not putting too much water or fertilizer on. And then you've got maybe a 4-week crop time on most pansies. So you basically have got 3 weeks. And oh no, you really don't have 3 weeks, because in that last week, the last 21 days, you're probably 2 or 3 days, you're getting your act together, you're putting fungicides on, you're doing all kinds of stuff to get it ready to go to transplant. So you really only have about 14 to 18 days when you can fertilize it. So if you're not fertilizing it every time it dries out, which is about every every 2 days, it's just not going to get enough nitrogen. And just like any biological activity, you got to have enough feed to get growing. Clearly, if you know Bill, you can see he's thin and lean. He obviously hasn't been feeding himself regularly. And if you look at me, you can tell I feed myself all the time. So we really have to be thinking of our plants as we've got to keep them fed 75 to 100 parts per million. More than that is just going to be a growth regulator problem. So let's talk about growth regulators. In the case of growth regulators, water management is your first tool. Make sure that you're managing that moisture, that it's going through the wet-dry cycles, so that you're getting the right amount of moisture on there, so that you're not putting too much to cause stretch, and you're not putting too little to basically cause problems. If you have the ability to have diff, which is the difference between the day minus the night, which that basically tells you keep the nights closer to the day temperatures, which during the summer is not a problem. During the winter can be a little bit more of a challenge. B9 application early on is very important. Now, the picture I show you is actually an example of too early of B9 application. If you get your B9 on too early, you get crinkle or hard leaves. And of course, we would like to have soft, supple leaves, not these hard, crinkly leaves. So anytime you start seeing this hard crinkle, go back and maybe delay your B9 application or drop the rate by a day, 2 days. And so you're not getting it on too early. And of course, that's a real challenge when you've got 20 different varieties in a mix, and they all have slightly different growth rates, especially the reds and the roses have a different growth rate than the yellows and the blues and the yellows. So you really have to make sure that you're putting on the early B9 application to kind of tone everything down and get it under control, because B9 is your first growth regulator and one of your best first growth regulators to put on, that you don't get it on too early. Don't jump the gun, but get it on top. As you go into the second and subsequent, usually you're putting it on every week. Tank mixes of B9 plus A-Rest gives you the greatest security because you can grow out of it. B9 plus Cyclacel, you just have to be worried about a little in the soil and a little bit of yellow leaf yellowing. Some growers will use B9 plus Florel to get excess, if they have excessive flowering, because Florel will knock those flowers out and then basically pushes flowering, delays it by about a week. Very beneficial under with violas, which tend to have earlier flowering than pansies. So, you can use the different tools of growth regulators to achieve the end result. Normally, we don't put bonsai on because bonsai will, of course, could potentially stunt the plants if you don't do it right. We tend to like to leave bonsai to a later time. If you want more specific information on rates, by all means, grab that Grower Talks, a guide to growing high quality annuals, the plant growth regulators document that that Whipker did from North Carolina State. Great resource, definitely get that. Let's talk about disease management, because disease is really critical. There's a couple of diseases. Thielaviopsis is our biggest concern because it looks an awful lot like Pythium, but it's not. It's much more deadly. Leaf spots are usually an indication. Anthracnose or Corynebacterium are usually indication that you're not feeding them enough, that they're running hungry, so that they're weakened. Downy mildew is unique in certain parts of the country. So if you're under a lot of downy mildew pressure, you may need to consider it. Preventative has got to be done from Thielaviopsis and downy mildew. So you've got to get it on before the disease. That's preventative. Curative, if you've got leaf spots or Pythium, you can basically apply a number of different chemicals that can be curative. So you can kind of delay the application until you actually have the problems. Again, check the Grower Talks insect, miticide, and fungicide guide for specific rates and different chemicals that are very effective. So hopefully, Bill, I think that kind of gets us through the high points on Pansy production. Are there any other thoughts that you have?
Well, you know what? A couple things came up, so I got to throw a couple questions that I had at you.
Okay.
First, to reiterate, it's all really about uniformity, and
Yes.
in terms of your watering, in terms of your coverage of the soil media. This is something you want to not have to go back halfway through the process and start correcting errors. You want to start strong, kind of like any crop, but it seems like extremely critical with pansies because they are so quick. So my questions are, and it just came up when you just talked about violas. Are there intricacies and differences between pansy and viola crops when you're starting them, or in the early stages, or do you kind of treat them the same way?
Early stages, pansy and viola are pretty much handled exactly the same. You get prime seed, same moisture. Violas might be a little drier than pansies as desired, but pretty much they're almost, people treat them almost identically. The biggest difference is that tendency to flower. The problem with violas is if you don't reduce the midday light, really a problem during the summer where you have bright, intense light. Make sure that about 10, 11 o'clock, you get the shades closed. And then you basically get them back opened up, 3, 4 o'clock when the sun's kind of down a little bit further, because that really bright light basically initiates flowering, especially when the days are long during July. August is less of a problem, but if you get into any early July sowings, you can bud them up. And then once they bud up, there's really no fixing them. You end up with stick in a pot. And that's not pretty.
Okay. And then my other question is just sort of a general overall question. We talk about growing pansies for the fall season, which is obviously the bigger of the two markets between fall and spring. Is it easier to grow pansies for spring because of the temperature, or are there just as many challenges that growers need to consider if they're growing a spring pansy crop versus fall?
Pansy, if you watch your moisture, you get your moisture targets and you make sure that you're hitting your targets, that you're cycling between your level 4 and level 2, that you basically at the time of sowing that you're putting on the right amount of moisture that you've determined to be optimum for your soil and your conditions. You hit the targets on moisture, it doesn't make any difference. It's virtually the same. If you don't do it, and that's kind of the point that you started into the questions about, if you don't get it started uniformly so they're all marching in straight lines, then you're going to have nothing but trouble all the way through. And the problem that you run into with pansies is they're so sensitive to moisture. It's very easy if you've basically got two populations separated by a week because they didn't all germinate at the same time. This lagging group is going to be wet and stay wet. And so the only way to fix that is to dry this group down, which then you put at risk of having tip abortion problems and other problems due to being too dry. So you run into this really difficult, you can't fix it. Okay. People have tried, it doesn't work well. And then growth regulator, you got the small ones and the big ones. They're separated by a week. You put a growth regulator and you nail this one to the ground, and this one you're doing really good, or you basically treat this just right and this one takes off on you. So this is why I really spent most of my time on this presentation on let's get the moisture right and helping you understand why it's so important to get the whole organization at the very beginning, before you sow your first pansies, on the same page about moisture and getting those more moisture targets and hitting them all the time.
Excellent. Okay, that makes a lot of sense. And as you can see, if you're watching this on video, we do have many more resources available. If you go to ballseed.com/quickculture/production guides, you'll find all sorts of technical documents, links to videos, and an excellent amount of resources. And would always recommend that you subscribe to the Tech on Demand podcast. It's brought to you by Grower Talks. Once you subscribe on really any podcast app, from iTunes, Spotify, Google, Stitcher, just about all of them, then once you're subscribed, you will get a notification whenever a new episode comes out. Then you can check it out. I also want to suggest that you subscribe to the Tech on Demand newsletter, which comes out every Friday. And we talk about relevant tips and challenges that growers are facing at that specific time. We also give you tons of resources to get ahead of anything that you might be facing in the near future. So thank you so much, Will. And we will continue the pansy discussion while we move through the other stages.
Thanks, Bill.